New technologies are pushing toward the battlefield at the same time. Autonomous systems, hypersonic weapons, engineered biology, and advanced communications are all moving forward so quickly that any one of them could shape the next fight. To avoid preparing for everything and mastering nothing, the Pentagon, now renamed the Department of War, has cut its broad list of priorities and focused its efforts on a smaller set of technologies it intends to lead. By choosing its ground like this, Washington isn't fighting for a place in the competition. It's playing its own game. When Emil Michael arrived at the Pentagon in May 2025, he stepped into the role of Undersecretary of Defense for Research and Engineering, the department's chief technology officer, and the official responsible for all major modernization work. However, the structure he inherited still reflected the unwieldy framework established during Heidi Schu's tenure, with 14, quote, critical technology areas spanning artificial intelligence, quantum information, microelectronics, advanced materials, space systems, propulsion, biotechnology, and more. Each field had its own principal director and roadmap, and the portfolio pulled the department in too many directions at once. Recent conflicts made the problem harder to ignore. Ukraine proved that constant adaptation to drones was a requirement for any military power. The Pacific pushed logistics, communications, and long-range operations to the center of every wargame. In Michael's experience in commercial Silicon Valley, companies pushed out new software builds, autonomy models, and hardware revisions every few months because their products depended on short competitive cycles. However, inside the Pentagon, even modest updates could take years to reach the prototype stage. To him, the department could not modernize at all until that gap was closed. At a public event in August 2025, Michael told reporters that the 14-item list had become too broad to guide anything clearly, and that the word critical had lost its meaning when applied to so many fields. He said the list would not stay that way, and that his office would begin tightening it with artificial intelligence at the top. Then, an announcement by President Trump changed the game. As Emil Michael and his team refined the Department of Defense's new list of priorities, the White House issued an executive order in early September to rename it the Department of War, a title the country retired after the post-war reforms of the late 1940s. The change was part of a broader push to strip away what the administration described as layers of caution and bureaucracy and to frame the department around direct military power. During the Oval Office announcement, Secretary of Defense Pete Hegseth stated, quote, "We're going to go on offense, not just on defense. So this War Department, Mr. President, just like America, is back." For Michael's office, the message was direct. A department now framing itself around warfighting would not tolerate slow portfolios or scattered priorities. By November 2025, the review was complete, and the official proved he wasn't bluffing. In a statement posted to X, he said the new priorities had a single aim: to deliver capability fast. His team applied the same tests to every field, looking for alignment with the Secretary's strategy, development cycles that could move in short milestones, and work that required coordination across the department. Areas that failed those tests were pushed to a lower tier. At last, after months of reviews and service consultations, the Department of War had a new Big Six. Just as expected, Michael made it clear that applied artificial intelligence will not remain a support tool that handles only menial tasks like paperwork or scheduling, but rather a central node in future operations. Ranging from target recognition to battle management, the new plan points directly to the White House's AI Action Plan as the strategic frame behind that shift. It also frames AI as a central point of competition with China, something Michael has echoed in several early public remarks. One of his first internal moves was to seize control of the Pentagon's AI office to consolidate scattered efforts. Much of this work is already visible in the systems the department is testing today. On Lockheed Martin F-35 Lightning II, America's fifth-generation stealth fighter, an upgrade called TR-3 and its Odin data network introduced software that sorts incoming signals in real time and helps the pilot make sense of the crowded information on the display. General Atomics has also been running autonomy trials on the MQ-20 Avenger, a jet-powered unmanned aircraft used as a testbed for mission software. One of those packages, cleverly nicknamed R2-D2, allows the aircraft to navigate, reroute, and manage sensors with far less operator input. All of these efforts feed into the Air Force's Collaborative Combat Aircraft program, which aims to develop uncrewed wingmen that can fly alongside fighters and bombers. Recent geopolitical conflicts have push this work even further. Software trained in Ukraine's counter-drone fight has given the Pentagon a clearer sense of how AI can track small, fast threats moving unpredictably through cluttered environments. DARPA has also been studying how to coordinate large groups of unmanned vehicles, a challenge that becomes increasingly difficult as the number of machines grows. But the list doesn't end there. The second priority, biomanufacturing, takes this list into a whole different realm. Instead of relying on long supply chains or imported petrochemical products, the Pentagon wants to produce basic materials using engineered microorganisms, brewing coatings, lubricants, or repair compounds in controlled vats, giving deployed units a way to generate what they need without waiting for shipments during a crisis. AFWorks, the Air Force's innovation arm, has supported small field systems that can produce spare parts on site. DARPA's resource program is developing ways to turn waste into fuel precursors, and the Marine Corps has tested compact microbial recycling units for forward bases. The third priority, contested logistics, is shaped almost entirely by China. In a Pacific War, Beijing could cut off U.S. ports, airfields, and supply routes with little warning. Keeping forward bases supplied becomes its own battle. The Army has been testing autonomous convoys. The Navy has explored short-range resupply between ships using modified V-22 aircraft, and DARPA has supported the Sea Train concept, an unmanned transport for longer distances. If and when a high-end conflict breaks out, commanders expect GPS and radio links to be among the first systems China targets. The fourth priority, quantum and battlefield information dominance, aims to keep U.S. forces communicating and navigating even when satellites are jammed or blinded. Among the research efforts in this area, one of the most interesting is DARPA's Ouija program, which explores navigation methods that rely on natural signals in the atmosphere rather than GPS satellites, giving aircraft and missiles a way to determine their position even when traditional guidance is disrupted, making America nearly impossible to shut down. The fifth priority, scaled hypersonics, moves hypersonic weapons from prototype to production. These missiles travel above Mach 5 and have become a major focus as Russia and China deploy them. DARPA's Glidebreaker explores ways to intercept hypersonic threats, while the Joint Navy-Army design underpins both the conventional prompt strike and long-range hypersonic weapon programs. The sixth and final priority, scale-directed energy, focuses on fielding lasers and microwave systems in numbers to counter cheap drones. Work includes the Helios laser on a Navy destroyer and the Army's truck-mounted system, both designed for fast, low-cost shots during saturation attacks. While the old list tried to cover everything at once, from materials science to wireless networks, this meant no single effort truly stood out. Now, as the new Big Six cut that spread in half and points directly at what the Pentagon thinks it can get onto the field soon, most of the former categories are not gone so much as absorbed, like computing and interface projects moving under applied AI, and pieces of microelectronics, materials, and even energy slot into logistics or biomanufacturing. The main difference now is focus. The new list will receive the lion's share of high-level attention, the Undersecretary made clear. According to Michael, quote, "These priorities will ensure that our warfighters never face a fair fight." For the defense firms, it's a signal of where the Pentagon intends to put real money and real effort. Michael has noted that private companies already invest $200 to $300 billion per year in AI, and the department plans to draw on that rather than rebuild it from scratch. The official has also pushed for shared risk to move faster, pointing to unmanned aircraft programs that can go from concept to prototype in a short period of time. The Department of War's top 6 priorities reflect an attempt to deliver meaningful capability within roughly 3 years and to link military progress more closely to commercial research. A lot more information and direction will likely come at the 2026 Defense R&D Summit, but the outline is clear. These areas are what the Pentagon believes it must focus on now, because the alternative is simple. If America hesitates, it's the country, not its contractors, that will fall behind.